Yeah, we're going to start into the project presentations talking about Digital Water City. And our first speaker is Dr. Nicolas Caradot. He's going to talk with us about the benefits of digital solutions for the water sector. He's the project coordinator at Berlin Center of Competence for Water. And Nico is also the coordinator of Digital Water 2020, a recently founded group aiming and addressing synergies and complementarities between 5 digital water projects. So that sounds really exciting and interesting. Nicolas, the stage is yours.
Okay, thanks a lot. So good afternoon, everybody. My name is Nico Caradot, working at KWB in Berlin, and I'm very glad to be here to present you our projects, Digital Water City. So it's a €5 million project that started already 2 years ago, and that will go for 2 more years. And in these projects, we are working with 24 partners all around Europe, in 11 European countries and Israel, to develop a series of digital solutions. So this is actually the main objective of the project, is to develop a series of 15 digital solutions to address different, very various water-related challenges. So at the core of the projects, we develop the solutions. Then we focus on the integration of the solutions into existing systems of the utilities, solving issues of interoperability, cybersecurity, for example. And then the main objective is to show the benefits of this solution, to demonstrate the added value. And for that, we are working with 5 cities to assess the benefits for different objectives, which are, as shown on this diagram, the protection of public health, the optimization of investment on urban water networks, and the involvement of the public into urban water management. So I mentioned 5 cities. Here they are. We are working together with Paris, Milan, Copenhagen, Berlin, and Sofia. And what's quite interesting is that we have very different objectives in each city, which are presented very briefly here. In Paris, the main objective is to improve the river quality, or the bathing water quality, for the Olympic Games of 2024. There is the political objective to swim in the river for the Olympic Games in the Seine, and also to give that as a legacy for the Parisian after the Games. So Sofia Husni, that will present right after me, will give you a bit more detail on what we are doing there. In Copenhagen, the main objective is to reduce flooding and environmental impacts with digital solutions. In Berlin, it's also related, is the protection of the river quality and the drinking water sources. Whereas in Sofia, in Bulgaria, we are working on the optimization of return on investment and operational costs, mainly on the sewer network. And finally, in Milano, we work on safe water reuse for agricultural irrigation. So at the end, the goal of these projects, or the ambition, is to be a kind of lighthouse where we can show the risk and the benefits of digital solutions for other cities, to promote also the market uptake of this series of 15 digital solutions that we are developing in the project. So in the following, I will go quickly through the different parts of the water cycle to give you a grasp, a quick explanation on what kind of solutions we are developing and for which purpose. And of course, you can visit our website, digital-water.city, where we have a full detail of this solution. So I will start with the topic of bathing water. As I said, it's the topic of Paris. Sofia will talk more about this, but we have 2 main technologies for that. The first one, it's a sensor developed by a French company called Fluidion for real-time monitoring of bacterial concentration. We can use it in the river. We can use it also at the treatment plant. And that's quite interesting because instead of taking grab sample manually in the river, we can have real-time information on the quality of the river and the risk of contamination with bathing. And the idea is then to use this data, as well as other data about water quality, with machine learning tool to predict water quality into an early warning system and use this information to manage the bathing authorization in the different sites. So assessing in real time the risk of contamination. And then we want to embed this forecast into a mobile application for the citizens in Paris in this case, but this can be replicated somewhere else, to communicate on bathing water quality and the potential of swimming into the river at the center of the city. The next topic is drinking water, or more, we should say drinking water abstractions. We are developing solutions for predictive asset management of drinking water wells. The idea is to have an application with the Berlin Water Utility. This is tested and developed in Berlin, to collect, share, and visualize all the data related to operation and maintenance of drinking water wells. And then, a bit similar to what has been presented before by Daniel Sauter and Matthias Rischel, to be able to predict the condition of this infrastructure and to simulate different investment or operational scenario on the infrastructures. For example, to identify the priority of maintenance on the short term. On sewer networks, we have different solutions that are being tested and developed. The first one, it's an innovative monitoring solutions for illicit connections. So illicit connections, they are wrong connections between the sanitary sewer network and the stormwater network in separate system, leading to untreated discharge of untreated wastewater into the environment. So here we deploy a solution which is based on a long cable that we install into the sewer network. And along this fiber optic cable, we measure temperature with high resolution. And from the variation of temperature, we can identify quite precisely the location of infiltration, for example, illicit connection or industrial discharges, which are very hard to find in other ways. The second solution is also based on temperature. Here, the idea is to reduce the cost for the monitoring of sewer overflows, which are discharges from the sewer network into the environment. And for that, the idea is instead of monitoring only the main discharges that we have on the network, to be able to install a very vast network of more than 50 sensors to collect information on the overflow. With these sensors, we don't know exactly the volume, but we can gather quite precise information on the beginning and the duration of the overflow. And the idea is to install the sensor at the crest of the overflow. Normally, we measure the air temperature. During the overflow, we measure the water temperature. And from the data analysis, we can identify quite precisely the duration of the event. And finally, the last solution, it's a solution for flow forecast. The idea is to be able to anticipate the flow at the wastewater treatment plant so we can optimize the retention in the sewer network and the treatment capacities at the treatment plant with a forecast horizon of almost 2 days. And here we go, speaking about treatment plant, to the next step. This is something we are doing in Copenhagen. We work on the real-time control of the wastewater treatment plant and the sewer network. Here, using algorithm to optimize the retention capacities, for example, during storm event, into the sewer network, and optimize as well the treatment capacities and the efficiency of the treatment at the plant. And this is something we are doing with more than 10 utilities in Copenhagen in the area that are sharing data from sensors and model to take together decisions and optimize in the best way, in an integrated way, the sewer network and the wastewater treatment plant. Lastly, we work on water reuse. This is something that we are doing in Milan with an early warning system for water reuse. This is basically a digital tool that aims at prevent bacterial contamination from water reuse for agricultural irrigation. So it uses all data that we have in the treatment plant, from sensors about quality or online monitoring of bacterial concentration as shown before, or the development of soft sensors, which are correlation between the available data and lab measurements to assess in real time the risk of contamination at the plant. And for water reuse, we don't work only at the plant, we also check what's happening in the field. So for that, we are developing some drones that are connected with sensor for remote thermal imagery sensor for remote monitoring of water stress. And finally, we develop a matchmaking platforms that somehow connect the information of water availability and quality at the plant and the irrigation needs from the fields that we can measure, for example, with this type of drone. And we create a new communication channel between the agricultural sector and the utilities to foster and facilitate water reuse. So this is being tested at the moment and developed in the suburbs of Milan. And last but not least, I mentioned it briefly at the beginning. So it's not about performance and public health only, it's also about public involvement. We have two solutions which are interesting to mention. The first one, it's a solution based on augmented reality that's being developed in Berlin to communicate the groundwater issues with the public. The idea is to show to the citizens, to the Berliner in this case, what's happening underground below our feet, to show that there is groundwater and to explain some issues such as the productions of drinking water. So where does the drinking water come from? Why do we have an amazing water quality in Berlin? What are the natural processes that happens below our feet? So to be able to communicate that better in an interactive way. And finally, we developed a serious game in Milan to communicate the benefits of reuse, not only in terms of water availability and quantity, but also in terms of nexus, meaning the impact that we have on energy, greenhouse gas emissions, or food production. Just one word, it's not the main focus of the presentation, but to mention that it's not only about technology and solutions, it's also about the integration of these solutions. There will be more also in the breakout sessions after. So we work a lot on the integration of this solution into the existing system, using tools such as Fireware or developing data model to make sure that our solutions can be used also in other cities during and after the project. So that's it from my side. That was a quite brief introductions, giving you first information on what we are developing and hopefully give you the interest to check a bit more in details what we do. In the following, we will give you more information on what we are doing in Paris. So that will be the next presentation with Sofia. And then after, you will have a short videos to show the solution and the demonstration that are running at the moment in Berlin. So hopefully giving a bit more information on what I just gave you now. Thanks a lot.